Hello and welcome all together to today's webinar, as always hosted by the OpenTelekomCloud community portal. Today we have a lovely guest with us, Anton. He will give us some nice information about Terraform, how to get started with Terraform in OpenTelekomCloud, what elements we as OpenTelekomCloud have here at hand for you as a user to use, how to use it, where to find what, and also we have prepared some nice live demonstrations, live sessions for you. And with this, handing over to you, Anton. Thank you a lot
Okay,
for having you here.
thank you.
Thank you a lot to all of the participants here in the call, and let's have a great webinar all together.
Okay, hello, welcome everyone. So, my name is Anton. I'm Code Dev Lead in Ecosystem Squad, the squad who are giving you some tools for developers, for DevOps who are using the OpenTelekomCloud. And right now, our main topic is Terraform, because we are developers of Terraform provider inside the OpenTelekomCloud. And as I understand, there are a lot of people highly appreciated of the stability and quality of this Terraform provider. So, and I want to share something about it. Maybe if you didn't know, didn't heard about infrastructure as code and Terraform especially. So I will discuss the very basic thing and then show some examples also. And please be patient because I am not a professional speaker. I am only the developer most of the time. So I'm just trying to bring you some new information maybe and teach you something new. So let's start. If you want to start from scratch with Terraform, so what you need, it's only the existing account in any cloud, not only the OpenTelekomCloud. For example, you could use any editor. For Visual Studio Code, there is such interesting feature called dev container. So you can run every code inside the dev container and not using your host machine. That's really convenient and so easy to start, not to set up something with your networks inside the machine and so on. Also, I have prepared materials for this session. You could find this link in github.com in our organization called OpenTelekomCloud Community and repository Terraform Workshop. All these there are not so short slides inside. There are more extended materials in this repository. So not only examples about the Terraform itself, but there are more about GitOps approach also with infrastructure and some interesting tools. But you could find everything there. Also, if you one point, if you open this repository inside Visual Studio Code, it from scratch will propose you to run this repository inside this pre-installed dev container. So you don't need to do anything. So, and let's start. What about infrastructure as code? Probably you heard already about this thing. Overall, this process of managing your infrastructure with code, with tools that use configuration files, typically declarative to consistently provision some hardware or services inside the cloud to some desired state with each execution. The main benefit, this is a idempotence, and this is some kind of fundamental principle for infrastructure as code. So from each deployment, there are no changes in existing infrastructure. Your infrastructure consistent every time. So for example, if you deploy some server which are already configured on the first time, so reapplying on the same configuration didn't bring new state of the server and didn't change anything inside the server. And from this, we could see the main benefits of infrastructure as code, that it's a reproducible infrastructure. The infrastructure is reliable, and you could recreate it in time manner on any different cloud or different region, in different availability zone, for example. It's easy to redeploy it, just apply the same code without any changes. It's also could solve your problem with infrastructure drift. So because it's ensuring the consistency of your infrastructure. So because all of your infrastructure inside the code, and you don't need to change or create something manually by click ops approach or something like that. All the infrastructure code also could be stored in any VCS virtual control systems code like GitHub, GitE, GitLab, and so on. So it's also help you to keep everyone in your team and maybe in different teams some vision of your infrastructure. So everyone knows how it looks like, how to use it, how to connect to it. Also, this approach could bring us easily automation. So you could implement CI/CD approach, GitOps approach, not only using some runners inside VCS systems, but there are a lot of some interesting projects. Looks like build servers, for example, for infrastructure, and they could get all work from your team. They just by themselves will clone this code and run it on their site, and that's all. So it also gives you some opportunity not to change anything manually on your laptop, and so it helps you also avoid some infrastructure drift. Also, there are a lot of different tools, not only the Terraform, for example, Ansible, Chef, or Puppet. You could also use these tools for infrastructure, not only for configuration, but the main benefit of the Terraform in that case that it's created only for infrastructure management, not for everything, and it has some features baked inside for parallelism, for backoff and retry, so you don't need to create another bicycle if you're using Ansible, for example. But also these tools are very helpful if you're using in some combination. Also, lately I will show you an example how to combine for example, Ansible inside the Terraform, but also in that case, Terraform will be managed everything inside. So it looks like a monorepo. So you don't need to split the code by parts and run it independently. So everything in one place. So, and let's start with Terraform itself. So, what is it? The Terraform is a tool created by HashiCorp at the beginning. So, and you could use it in two mainly modes. Basically, every engineer used it only as CLI, but HashiCorp also offers you some cloud solution, but it's not our case. So, but also if you're enterprise users, you could deploy it as this cloud solution on your site and use it there. So also because of some changes in the license not so long ago in the Terraform, there appeared some community fork called OpenTofu. It's completely community version, also with complete support of all Terraform providers. And few words about the providers. So the Terraform, it's only the code, only the tool which uses these providers to access some APIs, not only cloud APIs, but also for different tools. For example, you could manage from Terraform not only some resources inside clouds, but also create some database instances on different maybe bare metal instances and configure these instances. Also, for example, if you are deploying your infrastructure inside the Kubernetes clusters, you could import the provider called, for example, Helm, and from Terraform, you could manage this Kubernetes instances from this Helm provider by giving them only some connection string or configuration to connect to this Kubernetes instance. So, and how to say, the base part of the Terraform is the providers. You could find this really huge list of the providers inside the official registries. For Terraform, this is URL presented here, registry Terraform.io. For Tofu, you could just navigate through Google and open it. But today, in my examples, I will show you the Terraform version because OpenTofu has some issue with state file, so it's not so easy to read it. It has different schema inside, so you need to pretty print it. So how to start with the Terraform? Okay, you installed on your machine the Terraform binary file. So next you want to connect to some API, probably OpenTelekomCloud API in our case. So in that case, you need to create this block called provider and give them some authorization methods. Here presented some basic authorization based on username and password, but our provider also support cloud authorization as for OpenStack and a KSK authorization also. So you need only create this block, put authorization method, and that's all. You could use our cloud, you could connect and create some resources inside. So maybe if you're using different regions, you need to also use the region variable here, but if your base region is UDE, so you could omit this variable. It's not required here. So, and this especially block just tells that we are using OpenTelekomCloud API in next steps and in this region with these credentials. So, and that's all. So very basic. So Terraform, as you can see, uses their own language called HashiCorp configuration language. But it's pretty similar to the normal programming language, maybe scripting language, and looks like more or less like the maybe Ansible playbooks and so on, so on. And it's also support these basic blocks for the configuration. For example, you could use the variables to store your data inside them. You could export data after creation some resources, but using output block. And also another feature of outputs is to send some information between different blocks of the infrastructure from one to another. Also, if you split your infrastructure for modules, or could also call it packages, every package could export this data by outputs, and you could take this data to another module and reuse them there. Okay. So also I will show you later, but it how looks like the minimal infrastructure block inside the Terraform. So you need to create a block called resource. Resource, that means that you will create some resource. There are of two type of main resources inside the Terraform. One called resource especially, and another is data source. Data source you are using when you need to read some pre-created data from the cloud for future use in another block of your resources. For example, here we are using a resource called OpenTelekomCloud compute instance, which will create some virtual machine inside the ECS service, and we could use here that we are using a lot of variables and maybe some hard-coded values for the flavors. But also, for example, inside the network block, when we connecting our resource to some part of the networks inside the OpenTelekomCloud, here we use some link to another resource, but also it could be a link to data source. But data source link will start from keyword data. So also I will show you later this type of feature. So, and here we come to some interactive scenario, and let's in this example created by me. So it's also based on creating this simple compute instance only and install some basic software inside it. So, and for that we need to create some resources, of course. I started from the variables. Also, Terraform not so strict. It's not important if you want to split by different files or keep every infrastructure inside only one file. So it's only up to you how you want to manage your infrastructure. But for me, it's more convenient to split somehow variables in separate file. For example, the main logic and main file, the connection strings and provider setup, for example, in provider. So when we want to start the implement some infrastructure, first of all, we need to use the block provider and block the Terraform. Terraform just navigate the Terraform binary to our special provider called OpenTelekomCloud, for example. So in this block required providers, you just bind the link to registry, to real registry, and then when you run the command to init, Terraform binary will understand that you want to download this OpenTelekomCloud provider with this version above 1.36. Sorry, Terraform init. So in this step, Terraform will download and put the Terraform provider binaries inside this work directory. So could also find that Terraform not only download our provider, but also some local and null resource in Terraform, because we are using these resources inside our configuration. And for this resource, you don't need to put it inside the required providers because it's somehow stitched with Terraform binary itself, this kind of resources, because it's inside the HashiCorp registry itself. So, okay, when we finish this setup, the basic setup with the binary and the connection string for our Terraform, our OpenTelekomCloud, then we could create some resources. And what we need to create the compute instance. There several of resources we need to create. It's not so easy, but if you want to understand what you need to put inside some of resource, so good to navigate to the documentation, the official documentation. So also OpenTofu projects have the same registry with the same documentation, so it's just mirrored. And here a lot of guidance for different resources and different services. And what we need to search for compute instance. And here is a lot of examples and full description for every attribute, which is required, which is optional, what we need to put inside this attribute, and so on and so on. Which attributes are returned only, and how to, for example, import pre-existing resource, and so on, so on. So please, if you have any questions how to create, first of all, navigate to this official documentation for any provider, not only for ours. So, and here you can see for the instance, we're using a lot of variables, a lot of links to data source, for example. Data will, this data, for example, not to hard code something, we could just fetch the data from the cloud itself. Sorry, where it is? Okay, here. You could just use this block called data and compute flavor, for example, and by flavor name or by some regex, you could search some data, for example, for biggest flavors or some GPU-based flavors, and so on, so on. For images, the same. You could use image name, for example, if you want to use the Ubuntu or Debian or something else. We can use this attributes more recent, which will return only the latest version for this name of the image, and so on, so on. So, okay, we create our instance. What else? The main difference in the infrastructure as code and maybe different tools that mostly infrastructure as code and Terraform itself especially can count instance ready to use. But in reality, when Terraform or API return to us some status that's instance running or prepared to use, in some cases, we still cannot use it. So because of cloud init processes or something inside the instance itself. In that case, we need to use some approaches, how to fix it, how to not make our infrastructure not so reliable. In that case, we could use the null resource, which are provided from HashiCorp itself and Terraform itself. It's just empty block of the resource. It's just some kind of block with basic life cycle of the Terraform and nothing else. No code inside it. We could put inside it whatever we want. Any scripts, any maybe shell commands, and so on, so on. So here we could use some trigger. For example, if we are creating the instance and assign to it some elastic IP, or yeah, then when IP is created, this resource will be triggered. And how it could be triggered? It could be remote exec, which are running inside some remote instance, or it could be a local exec. Local will run this null resource only inside your local machine. So, and we need to use this block to understand when machine are ready to accept some commands. So in that case, we just check in the cloud init status and then just echo and the SSH is ready. For remote exec, we need to put this connection block to connect to instance cell by SSH connection, for example, using this host, username, some private key to connect, and with some timeout. Okay. And after that, when the instance really ready to accept something, then only after that we could use some tools for install the software inside it. And here an example how to use Ansible provision inside the Terraform. So all code in one place in this example. You only run the Terraform and Terraform will do everything. It just check the connection to instance and will run the Ansible playbook inside it. And for Ansible playbook, this is a different example. I'm using the local exec. It will use the Ansible playbook from this folder. It's just simple as such. So just install Nginx and ensure that Nginx are running, and also the Terraform will say that everything is okay. If playbook successfully installed, the Terraform will return to us some output, how to connect, how to look to this Nginx instance and to check if it ready to be used. So, okay, when we have this code full of different resources, we need to apply it. Apply means we will install these resources in our OpenTelekomCloud provider. So, and how to do it? Only the simple command Terraform apply. But good also to review your Terraform before applying. Also, apply will first ask you if you really want to apply this code or not. But good also before apply to use this Terraform plan. Terraform plan will build dependency tree for every resource pointed in this configuration, and you will see what Terraform want to deploy inside your environment. So there are a lot of resources. So this is a file for connection, this key, the Ansible provision, the SSH check, the volume for our instance itself, and so on and so on. Okay, for me it looks good enough, and we could apply. So you could also use the key for apply called auto approve, but I am not recommended on the production because it could destroy something and you will never understand how to fix it later. So then that's a good idea to every time use just simple apply, then review the plan of the Terraform, because Terraform will show if it wants to delete something, it will be called something like resource will be recreated or destroyed and recreated and so on and so on. So, and everything is okay, you could just put yes, and Terraform will start the installation of every resource from your infrastructure. So in that case, we need to wait some time. Probably could navigate to the console itself. Okay. We can see that our instance are creating right now. And already our resource what are checking the connection to SSH and state of cloud init already started. So you could see that creation of instance already completed, but we still cannot connect to it in reality. So in that case, you need to use this type of extra checking. And this is for all cloud providers, this thing. Okay, while this creation still, okay, it's already finished. So Ansible provision executing, and installing Nginx. So, and everything from the Terraform only. So you don't need to run different binaries in separate way in that case. So Nginx installed. Okay, and you can see also these outputs of our infrastructure code. Okay, it's running, it's ready to use. So, but in more complex way, of course, you need to put the Nginx, different Nginx configuration inside here. So also, there are a lot of commands for Terraform. Terraform, for example, if you already installed some infrastructure and you want to see something, what are there? You could use this outputs command to print, for example, all outputs, or the one of the main feature of the Terraform, how it stores the state of the infrastructure. Everything is stored in some file called tf-state, and sorry, not this. No, this one. Because I'm using a remote host, so I need to download. So the Terraform state looks like this. This is just one file, which contain every resources, every outputs. So you could see the resources and their attributes which are stored inside the cloud. So, and you definitely could use these values from the state to reuse in another resources by calling it by resource name dot name of the resource and dot some specs, availability zone, extra spec, and so on and so on. So to reuse it lately in different resources. And you could see there are a lot of resources. So Terraform based on this state. So, and you need to keep it with great care because without state, your infrastructure unmanageable. So, and okay, for that case also, Terraform has the feature if you want to use this Terraform not only for your local development, of course, it's hard to keep the state only on local by default. Because by default, it's only stored as the file on your local computer when you are running your infrastructure code. But if you want to create some production-ready infrastructure to use it within some team, so it's good to store this in some remote storage. It could be S3 compatible storage or something different because Terraform support not only supports not only S3 type of storage, but also console. Also, you could write your own storage or use some HTTP endpoints and for storing that. But it's recommended to use the storage which are supporting the locking of the state to stop some simultaneous running for one infrastructure by different people or different teams. And it's good to have the also storage with versioning support also. So this is the main thing to think about it, because you need to store this state with great careful. So also I want to show you some different features, advanced feature code. So because inside the Terraform there are a lot of pre-created lifecycle keys, and it could be called could be used for loops for creating, for example, multiple instances. Here, the example of count for each count if you want to create multiple multiple resources by indexes, and for each if you want to use some maps and iterate over the keys inside the map. So also the feature for the conditional, for example, if you want to create some extra instances, for example, for high availability, and you could use this parameterized creation. So to check, for example, if her availability variable are set, then we create 2 instances, otherwise 1, and so on. So, and also this, for example, for high availability, could be calculated based on some available regions or availability zones, not only predefined variable. And so also you could calculate some values based on created resources by using the local values. So inside the local values, you could take some values from resource and then manipulate with it and put inside some different place. Okay. And here just a simple example how to create some common tags in different resource by using these local variables. So, but these examples you could find also in this repository. And so about state management, I already tell you. And another important resource inside the Terraform called import itself. So if you already started to create some infrastructure manually or from different tools, maybe Ansible and so on, or Azure DevOps or something like that. So, and you want to bring the Terraform in your team, so it's good to use this feature of importing existing resource. So import just read the state of the resource from the cloud, from the API, and put this state in your state file and configuration itself. So also in our documentation, there are a lot of examples how to import different resources. Also, there are another topics called multi-tenancy, how to bring the multi-tenancy for the inside the Terraform. It's how to maybe combine different part of infrastructure from different clouds and so on, so on. So there are a few approach, one called folder-based separation and another called workspace-based separation. Workspace supported by Terraform by default. So, and you could switch between the workspace by using some common Terraform workspace, select, and then you could switch to another, for example, region or even another cloud provider. But in workspace-based approach, there are some. For me, it's biggest threat for your infrastructure. So if any case you switch to wrong workspace, you could lose all your infrastructure. It will be recreated or it will be just broken and so on, so on. So in that case, I prefer to use folder-based separation because all environment are separated by folders. So you could create some folder and put configuration files for production only and for dev only, but both of these workspaces could reuse the code, maybe baked in some modules, and so it will be really safely to use this. But previously, of course, in my experience, I'm started with using workspace because it's maybe easily it's you don't need to duplicate a lot of your code and so on. So, but it's in not so big infrastructure, it's really easy to switch between environments, but you need to be careful with that. So, and of course, it's up to you which approach to choose. Folder also for strong isolation or backend settings, or workspaces just for simplicity and so, and one backend for all. Also, all of this approach for multi-tenancy could be used as a hybrid approach. So some shared modules and separation method fits best for you. And also in this repository, you could find this example called Terraform multi-tenancy. Here, just some pre-created infrastructure code, which you also could run if you have some accounts inside that OpenTelekomCloud provider. And there are a lot of different features. So this code calls some Python code for create kind of Lambda function in our OpenTelekomCloud. And there are a lot of modules. So, and you could see in, for example, in dev environment, we have only the provider for connection to our API and only call for the different modules and not more. So it's how to separate the code. And for example, in the networking, the model looks like the simple Terraform configuration. So, and you can see the inside the, for example, networking model, a lot of resource for the VPC subnet, security group. Security group creates dynamically using the for each based on the local and local based on variable, which looks like this. Just a list. And in main model, this security group list just looking like that. So you just could add some port range, and this security group, for example, will be created in this network, and so on and so on. So maybe enough for today. So I'm finished.
All right, Anton. Thank you a lot. So you are finished with your speech. Then we come to the very last part, which would be the Q&A session. First question here is then coming in. Is there a repository where we can find some simple examples for code?
Simple examples are already inside the documentation. You just simple copy paste the block from the documentation, but also it depends of what you want or what you mean on this example, simple examples. Maybe We also have inside our GitHub OpenTelekomCloud a few Terraform modules. They also could be used as examples. Yeah. But basically, we are providing with each and every resources which are created inside for the Terraform. So we provide the proper documentation with a few basic examples inside it.
So what probably he's looking for is something like a blueprint, something in this direction here. So I think some blueprints you already saw right now also in the live demo part here. And yeah, Terraform is, I think, such a big thing that is pretty hard to really give there a blueprint because you can do everything in the whole cloud with it.
Yes, if you want some special blueprints, please come to our GitHub, raise the question in discussions or inside the issues, and we will help you.
So you see here also the email address from Anton. It's the very first one at t-systems.com. So when you have there something very special in mind, then I think best case scenario would be to directly get in contact with Anton related to this. Okay. Thank you a lot for joining, for having you here. Even more important, also, thank you a lot, Anton, for the nice preparation of this session here and being our speaker of today's slot. And see you hopefully all again in the next webinar hosted by the OTC Community Portal. Thank you a lot and bye bye.
Thank you.